Good morning. Oh, just saying that woke up my voice assistant. I've got to mute it. But, Scott, what do you mean the other button? I don't know if I want the answer to that question. So, good morning to everybody. I will do some good mornings in just a second. But just as a little bit of a change of pace, first, I just want to do a shout out. Not so random shout out to Professor Sandra Eads. This is in recognition of Aboriginal Australians who have done amazing things. And Professor Eads was the first Aboriginal doctor to be awarded a PhD, which was investigating the causal pathways and determinants of health among young Aboriginal infants in their first year of life. She's won many awards and done some incredible work, so she deserves some recognition. And this is from the University of Melbourne profile page. She's a professor there, I believe. So, yes, she is currently a professor at the Centre for Epidemiology and Biostatistics at Melbourne School of Population and Global Health. So, very amazing person. Anyway, good morning to everybody. Who is here? Keith wasn't quite first. The chat has done the weird thing where it chops off some of the early things. It's not showing everything, but so good morning to Keith, Michael, Gerald, Outside the Box, Gavin, Sion is here, Moo to you, Dodgy, Michael, and Austin is here, James. Austin, I saw a comment from Austin about working on CAN. We're going to be doing some CAN today. I hope we get to this. It's not going to be the silent movie today because I think my microphone is working. Who else? Andrew Brown. I'm probably missing people as I'm just quickly scrolling down. I'm not even looking at messages. I'm just reading names. David. Alistair. Thanks for beaming in from Canberra. Stephen. Simon. Amanda. Russell is here. Chris? Chris is here. Good evening from St. Louis, MO, USA. Thanks for coming so far. It's a long trip to get here. Trady, David, Celtic Beast. David, you want to see the magic smoke escape? If there is any magic smoke today, it's going to be virtual smoke because I'm going to be working in CAD, not actually building the board. So, Mad Jackie is here. All right, so I'm going to John really needs a hand mirror with the glass removed, says Scott. What's that? A hand mirror with the glass removed. I don't know what that means. A hand mirror with the glass removed, just so I can look through it. Okay. Now, Gerald made the comment, CAN is quite relevant for more people. It will be on the new Arduino boards. And yeah, it's just so I don't have to look at myself. It's all right, I don't look in the mirror. That's the way of avoiding that problem. I just avoid any reflective surface. Scott says some of us old fogies will get the reference. Okay. There is obviously some cultural reference there that I am missing. Now, I am just closing up some windows because I'm going to bring something up that got my attention this morning. Okay, I am going to get into some design okay, so the agenda for today is a little bit of background information, lay out some requirements, pull up some pre-stuff that I did playing around, and maybe start putting down a schematic and maybe like some rough board stuff. And this morning I opened my email just before starting the stream, and there was an Arduino newsletter. The thing is, this may be old news to everybody else, but they in the newsletter they referenced this as a new board, Arduino Nano ESP32. And that threw me because as far as I know, this is the first time there has ever been an official Arduino with an ESP on it. I may be wrong about that. I haven't really been paying a whole lot of attention to official Arduino stuff for a few years now. It's just, it's kind of sad, but it hasn't really seemed all of that relevant. They keep seeming to go into making boards that are slightly oddball and short-lived, probably like boards that are developed in conjunction with other companies, probably because the other companies are trying to use the Arduino brand name to showcase their microcontrollers or something. So they'll make a board, it's an official Arduino branded board, but it might have been developed by some vendor and put their, yeah, it's like a brand management thing. Does it have USB-C? I just saw Celtic Beast just said, does it have USB-C? I don't know. Looking from the top of it, it looks like a USB-C connection. Look at all the pins that are along the back there. Click to expand. That looks like a USB-C connection, yes. Can we see it from the end? It's a weird connector, but yes, that's a USB-C connector. It's very trimmed back around the cover here. So this module, I believe, has an ESP32S3 in it. Don't know what that is. Oh, it's got looks like it's only got 4 connections on this side. That is most likely a memory chip. And then, okay, so the point of this though is that it made me think, hang on, if Arduino have released an official board, then that must mean that they have added support to it to the Arduino IDE. And yes, they have. So it is now, where is it? I'm just on another screen opening something. I'll bring it up in a second. So if we go into Boards Manager, I hate the fact that this, yes, I know this is the old Arduino IDE, but I was also partly curious to see if they were supporting this in the old IDE and not just in the new one, and indeed they are. But the annoying thing is it does this downloading platforms index every time, which takes forever. And so if we just search for Arduino ESP, that should do it. So there is ESP32 by Espressive Systems. This is the one that I've got installed, obviously, because I've been using this profile for a long, long time, which has been updated many times. But look at this, ESP32 by Arduino. I don't know if that's just like a rebranded fork or what, but it is there. There is an actual Arduino official ESP32 profile there now, which I don't have installed, but yeah, that is interesting to see. It's an interesting development. Oh, Emmy has made it along as well. Welcome. Yes. Yeah, Trady Trev says, odd as USB-C connector. Never seen one like that before. Neither have I. It's like it's missing part of the shroud. It's cut back or something. Austin says, Arduino IDE has had ESP32 plus S3 support for quite some time. There are some issues with library naming on S3 interfering with old libraries, but nothing that can't be solved. Yeah, but Austin, is that ESP32 and S3 from the official Arduino team? Because I know I've been using ESP32 S3 with Arduino myself for a little while, and it's supported in that Espressive profile that I just had. But yes, Henrik, I'll get to the PCB. This is related to it. This actually leads into it. But has there been an official Arduino ESP profile up until now? I don't think there has been. But as I said, I haven't been paying attention to that, so maybe it has been around. Yeah. Right. Michael, get that heart rate back down again. All right, so the relevance of this is, for the project today, the question of what processor to use. And I was already leaning towards using an S3 on it, and this kind of just makes it it doesn't really make a huge amount of difference because I probably would have used an S3 anyway. But I just thought it was interesting that the timing came up that this morning in my email was the Arduino newsletter announcing this board, and it's an S3, and that's what I was about to talk about. Yeah, right, so let me show you what is going on. What is up, YouTube, as they say on all the popular channels? Dropbox, camera uploads, looking for some pictures because I'm going to show you what it is that I am trying to achieve here. All right, now first, I'm just going to hit mute on my computer because I'm going to open a video and put this, drag this up here. So this is a view inside. Oh, that's a long one. 1:33. Okay, maybe this isn't the right video, but anyway. So this is a view inside one of my Kayo pick and place machines, and this was a few days ago. When was it? 21st, so 2 days ago. This is when it was doing a job. So you can see the whole machine there is shaking. This was after, there's a bit of an embarrassing thing here. In the protocol that communicates with the machine, I keep thinking about extra levels at which I have to jump back to explain, because I'm assuming you already know heaps of things. This particular pick and place machine came with control software which runs on Windows 7 and which communicates via a serial interface. The machine itself has a motion controller built in, and the Windows software sends commands using a binary protocol, and it's an 8-byte protocol, and each of the bytes has specific meaning. So there are different commands and then different parameters to the commands, and then there are response messages that come back. The control software is horrible, and so I've been running it. So this is being controlled right now with Open PnP. Oh, you can see there was a part failure. It just went to the reject bin. And so the figuring out what the protocol is, yeah, it's failing to pick up on that part. There was something wrong with that feeder. Oh, I think I know what it was. Yeah. Oh, that feeder was, the cover tape didn't retract properly or something. So most of the protocol decoding work was done by Glenn English, who I bought the machines from. He implemented a Python interface for this thing, and I wanted to run it with OpenPNP. So what I did was, I'm just looking back in my pictures again. What I did was make maybe it hasn't synced. Is this, yeah, I don't think the photos from my phone have synced, but while I'm checking that, I probably need to go into Dropbox and make it sync. Anyway, that machine was shaking. As you could see, it was moving around all over the place. You can see part of the culprit here, and I know Sion is probably screaming. So this machine is currently sitting on this platform, which is on caster wheels. In fact, the casters aren't even locked, I think. No, the casters aren't even locked in place. It's just sitting there. And I discovered a few days ago that I was sending the speed packet, like the XY movement commands, using the default speed setting of 0, and it's got speed settings of 0 to 7. So I changed the protocol parser and made it send a speed setting of 7 instead, and that's why the machine was rocking around. It's normally a lot smoother than that. And also the camera was sitting on a tripod on just on the floor, so it was dead solid, very stationary, and the machine was moving. Now, what am I doing? Oh yeah, that's right. I was looking in Dropbox. I'm going to see if I can get Dropbox to sync off my phone, because I have some photos. Now this photo I actually took because I've just put an air receiver. The compressor is some distance away. So there is an air hose. In fact, you can see this bit of blue hose that goes up here goes to a, yeah, you can't quite see it in the field of view. That goes to a connector that then goes to an air hose that goes up to the ceiling, goes along and then through into the loading dock, which is where my air compressor is. So the compressed air is coming over a long air line to get into it. And then just during the week, I added this as a receiver. So this is additional compressed air. There's no air compressor in here. All it does is it's basically acting like a big capacitor. So we've got compressed air that comes in here, comes through this pressure regulator, comes down to this T-piece, just here, and one side of the T-piece comes to this tank, and which you might be able to tell from this is a converted fire extinguisher. And then the other side of the T-piece travels along there, and you can't quite see it, it's out of the field of view, but it goes up into the machine, which this gives local compressed air. So as the machine uses compressed air to do things like fire the solenoids for the feeders, it's kind of bursty. So it's very, very analogous to supplying power to, say, a microcontroller, and it's taking little chunks of power as it does things. So having local capacitors around it helps smooth out the supply rail. And this is like a big fat capacitor sitting right next to the supply rail, which, well, connected to the supply rail, which is the compressed air side of it here. Now, it's a surge tank, says James O'Gorman. Yep. Doji says, if that is its final resting place, it wants to be placed on some blocks and get it off those wheels. It needs more than blocks. It needs to be raised about 800 mil... how far? I think it needs to be raised about 500 millimeters or 600 millimeters. Something like that. Because the conveyor is actually really low at the moment. This machine is normally on a stand, like quite a big stand. But I don't have the stand for it. So it's not meant to just sit on its feet like this on the floor. It's meant to be raised way, way up. So I need to build a large, I fabricate a steel stand or something to put it on. Matt says the air tank matches the colour scheme perfectly. Yeah, because I painted it. It was red until about Wednesday. Classic fire extinguisher red. Austin says, on my recent boards I've used the ESP32 S3 Vroom 1U N16 R8. Okay, cool. That is possibly similar to what I've been using. Also, Henrik says, also I fixed my PCB from last week. Cool. So, anyway, part of the point of this, has my phone synced? No, it has not. It still hasn't synced. I took photos last night and they just haven't appeared. I took photos specifically because I wanted to show you what I'm currently doing. Just up in the top here, if I zoom a bit, it's not a very good view because it's zoomed way in. But anyway, what you can see there, this thing right here, that is a rack 32, and that is currently my interface to the machine. And what you can see there, this little thing here, there's a pluggable 3.81 millimeter screw terminal thingy. That cable that comes down from the machine here, this is the serial interface for it. It's 3.3 volt logic level. There are just three connections. There's ground, TX and RX, and that's it. And the way these machines are shipped, they come with a little module that this plugs into, which provides an RS232 interface. No, not a USB interface, an RS-232 interface. So what you have to do is, well, normally this is controlled, so it's weird how old this stuff is. So they ship with a PC motherboard, which is built into the bottom of the pick and place machine, running Windows 7 with an RS-232 port on it. And then the module that this is connected to plugs into the serial port, and it talks to the motion controller, which is inside the pick and place machine. So what I've got here, and what Glenn had done, was he had the module. Can I? Yes, Michael says, I see a case for CAN bus. Exactly, and that's what we're going to be doing today. So what Glenn did was he had the UART to RS-232 module plugged in, and then plugged into that a USB to serial converter, and then the USB to serial converter went to a PC which was running his Python control thingy. Yeah, Trady Trev says RS-232 is pretty rock solid when configured right. Yeah, nothing wrong with it. It's just this is the way it came, and it's not the way I want to run it. So what I've got at the moment is the expansion header on the top of this rack 32. It exposes the second serial port on the ESP32. So I've just got ground, TX and RX connected through there, and then my protocol converter code runs on the rack 32. So there's one of these cables will be a USB cable, I can't tell which from here, which goes into the back of the computer. See, there's a computer here. That's a PC running Ubuntu with OpenPnP running on it. So that's a Linux machine which is running OpenPnP, sending G-code over the USB connection to the rack 32, which is running my protocol converter code in there, and then sending the commands to the motion controller in the pick and place machine. And it receives response codes and parses them, and then converts them back into G-code type responses that go back to OpenPnP. So OpenPnP can do things like send a command to open a feeder, and then it waits for the response to come back to say, yes, the feeder is ready. Right, okay, so it does the job. It actually works. As you can see, going back to here, like, this is it as of 2 days ago, running a job, putting parts down. And this is controlled by OpenPnP through my protocol converter, talking to the original motion controller, which is totally unmodified, running in the Kayo. Now, why do I want to do anything more than this? All right, now, there are some other things that I want to add to the system. First, I need conveyors, and I already have. I wish my thing had synced, because I have photos somewhere. Photos home. Let me just see what's going on with my phone. No, I have a feeling that it didn't even take the photos. Anyway, I need to add a conveyor in, and I want to be able to control the conveyor. The conveyor controller that I've already designed has CAN bus on it, so that I can send a command and have the conveyor adjust its width to whatever I've told it that it needs to be on. So I'm wanting to add a couple of things. Now, the simplest possible solution to this, to make a... Okay, so my stated goal is to have a USB interface that I plug into the Kayo from a computer, and it appears as a G-code driven machine, just like a 3D printer or something, so that OpenPnP can control it natively. Well, native to OpenPnP. The protocol converter sits in the middle. So the minimum viable thing to do that is an ESP32 with a connector. that's it. I basically, say, imagine I had an ESP32 with USB on one side, and on the other side I've got the serial interface and the connector that suits the little three-way, in fact I have one right here, the little three-way pluggable screw terminal thingy, and then I could run my converter code on it. But I've got ideas that I want to do a whole lot more than that. One is the device, I want to have it also talk to other devices as part of this system via CAN bus. They could have their own interfaces, but anyway, I thought I'd just throw a CAN bus interface on there to simplify things. And Stephen W says, will all the converters and conveyors be on the same CAN bus to sync with? Yes, that's the idea. So what I want to be able to do is, in OpenPnP, I have configured it with what's called an actuator in OpenPnP language, which is basically an arbitrary action that puts a button in the user interface to do something. And then what you can do is configure, when you click that button, it might send some G-code or run a script or whatever. I've got an actuator which sends G-code to my protocol parser, which then tells the Kayo to adjust the width of its conveyor. So these two green lines that you see here, those are the conveyor belt. In fact, I wonder if I've got, I don't think I've got video of it ingesting a PCB. I may, I don't know. Where's a, just going to see if I can find another video. No. Anyway, I want to get on to actually doing some design, so I've got to kind of rush through this first requirements bit. Where was I? Yes, so a couple of other things. Down the bottom here, you can see this camera. Oops, I wasn't trying to move it, I was just trying to select. This camera that's on the bottom, this is not the original camera that came with the Kayo. This is a little camera module, an ELP something, I can't remember the specific model. They make a number of, it's like a little industrial camera with a USB interface. And it's got an LED ring around it. You can see that there's the original LED, whatever, the illumination. Now if I run it again, what you'll see, oh, just there I had it caught, the LEDs turned on. What happens is that when the vision system is running, it picks up a part, so you'll pick it up, takes it over the camera, turns on the LED, takes a photo, and then OpenCV does all of the alignment correction. So it's controlling the lights. That camera, however, has a USB interface, and that camera is connected to the Ubuntu computer running OpenPnP. So the camera has zero connection to the computer, to the pick and place machine. The pick and place machine, in terms of the chassis and the motion controller and all of that sort of thing, doesn't have anything to do with it. The camera goes into OpenPnP, which uses it to take pictures of the parts to do the alignment correction. And likewise, there is a camera mounted on the head up here, which keeps moving around, pointing down, and that down camera is used for things like finding fiducials and setting pick positions on feeders and all that sort of stuff. That also has no connection logically to the chassis. It has a video output. Oh, you can see a failure there. It has a video output, another failure, which goes to the computer. So the computer has two USB inputs. Now the top one I'm actually sending in through an RGB to HDMI converter, then an HDMI capture device, which is on USB. But anyway, you don't need to care about that detail. The point is, there are two USB cameras that we care about capturing. The other thing is that these feeders down the back, now if I get the gantry to move so you can see it, these blue feeders at the back, these are 3D printed feeders that came off Mick or Make It, my homemade pick and place machine, and I've made a mounting rail with some 3D printed brackets there that hold the rail at the correct location, and then the feeders are supported above the Yamaha manifold. These have a much higher density than the Yamaha feeders. I can fit far more of them on. They're much narrower, and also I already had a whole heap of them loaded with different things on Mickle Make It, so I just transplanted feeders from Mickle Make It onto this mounting manifold at the back of the machine. And what else? Yes. Don't. Yeah, Celtic Beast says, don't stick your fingers in the gears as per the warning sticker. Yes, it is. Yeah, it says caution, mechanical injury. Yes. Does it mechanical injury? I think that's what it says. Caution, mechanical injury. Yeah, this thing is scary. When it's running at that speed, you just do not get a concept of how fast it is when, hang on, I'm going to turn on sound. When it's, yeah, when you're standing there and it's moving like this, it seems a lot faster than it looks on camera. Like you watch it on camera and you think, oh yeah, that's moving. But then you see it in real life with the cover open in front of you and you go, oh crap, I'm not putting my hands anywhere near that. I'm staying well clear. Yeah, so requirements. Okay, USB interface for the host computer. And this is why I'm talking about these cameras right now. And the feeders at the back. I like the idea, well, I kind of do and I don't. From a neatness point of view, what I would like is a single USB port that I plug in and I get everything. So I get the motion controller interface, the camera interfaces, and the additional feeder controller. So there is a second, there is an Ether Mega actually sitting in under the back of the machine, which is controlling these feeders up here. So those have their own, which is also a G-code based controller. So there is a second G-code controller to run the feeders. So there are at minimum 3 and most likely 4 devices to plug into the computer. And so I'm thinking of just including a USB hub in the base. Don said, I've achieved so much for relatively little outlay. Yeah, but the thing is, the outlay has all been in time. It has been a huge, huge amount of time. Sion was downstairs firing up his assembly line, which makes mine look like a little toy. Sion's equipment is very, very impressive. So, I'm just going to put this back to the start. Actually, I wonder if there's a different video. While I'm finishing off talking about what I want on it. Okay, so I want USB for upstream. Possibly a built-in USB hub for downstream feeder controller and camera, 1 camera, 2 cameras. I think it's going to be pushing it to get that much bandwidth. So I think just 2 downstream ports. CAN bus to talk to other devices on the chain. That's right. So what I was saying earlier is that in OpenPnP, in the user interface, in fact, this could be fun. I'm going to see if I can remote pull up the interface on that machine through screen sharing so that I can then pull it up and put it live on the BNC, that one, maybe, so that you can see live what the machine is doing. Oh, I'm going to have to log into it remotely first. I mean, I'm going to have to log into it in there first. So you'll be able to hear me, but not see me, just for a little bit. Okay, and got to move the thing out of the way. Turn on the machine. I'm not going to have any compressed air up and running, but that's all right. Now, It is logged in, so why couldn't I connect a second ago? Was I trying to log into the wrong machine? Maybe. All right. Connect. Maybe that one? No, surely not that one. No, not that one. Well, maybe it was just that I had to wake it up. That might be all it was. All right, I'm going to try that. BNC. No. Why is it not letting me log in? I don't get it. That is actually really annoying. I was logged into that last night. I want to solve this problem, but then I want to get onto other things. Yes. So, why? Like, seriously, that's bugging me. I wonder if it's the network connection to that machine. All right. I am going to, because I want you to see this, this is kind of cool. Even if this process has to happen over a period of time, that's okay. I mean, in terms of designing the board, I'm just dragging an Ethernet cable across, because one thing that I did was very late last night, I redid some of the network cabling, and I'm not even sure if we've got an active network. So, back again. All right. It was basically one of the last things I did very late last night before I... come on, log me in. Oh. Nope, it's not going to. Oh, that sucks. Okay, did you test your cable? Yes, I did. I think there's something else. The unexpected is taking over. Yes, says Stephen W. All right, so where should I begin? Now, there is one very major design decision. Just going to see if I can find an overall photo. Okay, here's an overall photo from, when was it? A week ago or something, just to give some context. So you can see there the three machines. This one at the front, this is the one that I was just trying to log into remotely. You can see the feeders at the front there. There's the second machine with its front cover open. There's a third machine back there, and you can just see there's a like a roll of tape sitting on it. And then the oven is down towards the end. So, and over the back there you can see Nickel Make It up against the wall, still with some feeders on it. But most of the feeders from that are now in the back of this first machine. So, in order, it is machine 1, 2, 3. The machine 3 is the factory machine, that's unmodified. 1 and 2 have been modified. Keith says, design decision, what color board should I use? That's, yeah, bike shedding. Now, just up here, you can see there's a monitor just sitting on top of the machine. There's a keyboard sitting there. There's a trackball sitting there. These machines are actually meant to be mounted up high. And on here, what's currently missing from it, if I zoom it in enough, you can see that there are 4 bolts there, and there's a hole with some cable sticking out. That is a VGA cable. VGA, super high tech. And there's a power cable hanging out as well, because originally there was a little monitor attached on here. I think it was like a 13-inch monitor or something. And then lower down on the machine down here, you can see that there are 4 bolts and a hole with nothing there. there was a tray mounted there, and that had a keyboard and a mouse on it. Or just a keyboard? I can't remember. I don't know. I've never actually had that. I never even received this. It was removed by Glenn. Or he just never installed it or something. He was never using this. So the idea is that this machine is meant to be physically mounted up significantly higher, so that this tray, this is down at like my knee height, but that should be at a keyboard height when you are standing up. This whole machine should be a lot higher. And the monitor that goes up here would be at face height when you're standing up. So now, there are two, I can think of anyway, two different approaches I could take for putting this controller on the machine. And the first is the minimal approach, which is a box that just sits down inside the machine with the USB interface on it, and I run a cable in and plug it in, and you never actually see the box. It's like a part of the machine. The other is to mount something way up here. Oh yeah, Sion. So Sion says, feed us your knee height. You're going to break your back leaning in and out of the machine after a while. Yeah. I don't want it to stay at this height. I want to build, I want to fabricate steel frames, because you can see that the conveyor down here, it's right down. That is down at my knee height. And that needs to be at 800 and whatever the SMEMA standard is. It's like 820 millimeters. I can't remember. Might even be higher, like 900 and something millimeters off the floor. So that's all got to be, yeah. Oh, David asked, do they have to be steel frames? Can they be timber? Technically, I could build them out of timber, but yeah, I think steel is better. I want them to be really heavy and solid so that they can be bolted to the, maybe bolted to the floor. I'm not sure. And yeah, and also steel I think is probably a bit more stable over time, particularly if I have a relatively stable temperature in this room. So it doesn't have the expansion contraction. Yeah, Trady Trev, I will do my best not to damage my back. Now, the other approach I've been thinking of is using something like the touchscreen interface that Austin and others are very happy with, and making something like in a 3D printed enclosure that mounts up here where the monitor used to be, or it could be on the front here. So I could make a little touchscreen ESP32 based thing, and that could be showing status of the machine. It could provide an interface like jog controls or like homing button and all of those sorts of things that could be done through the user interface directly on the machine rather than through OpenPnP. But I'm not sure if that's actually useful, because if I jog the machine around using a touch screen, then OpenPnP doesn't know about that. And although the position feedback would give, it is like a closed loop position thing, so the machine reports its position back to OpenPnP. And I'm in two minds about it. I could have like I can visualize how this would be. It would be kind of nice. I'd have a little touch screen at like a leaning back about 30 degrees, and it'd be in a 3D printed enclosure up here. I could walk up to the machine and press the buttons and, you know, hit home and have it do its homing cycle and jog it around and all of that sort of thing. But the thing is that all of that stuff I do out of OpenPnP anyway, and most of the time I control it sitting right here at my desk. So as I've been doing these jobs, this is why I'm so annoyed that I can't remote onto that machine. I want to show you the interface, but anyway, yeah, what I've been doing is I will sit here at my desk and VNC to OpenPnP and then just drive the machine from here. and use the cameras and everything. I can see everything that's going on and stuff. So the idea is that it should be rare to be controlling the machine directly standing at it. Now, one thing that I do have is, alright, I'll show you what I've got so far. This is all going to, I was playing around with this a while ago and then never really got anywhere. I took some existing project, I can't remember what it was. When was I doing this? What's the date on this? It'll be a while ago. Yeah, 10 months ago. I started working on this with an ESP32, and what is there? There's nothing interesting on this sheet at all. It's just an ESP32 with voltage regulator and USB to serial converter. Oh, what's up there? Yeah, that's it. What's on the sheet 2? Oh, sheet 2 has CAN bus interface and the Kayo serial interface. And this is literally the serial interface to the Kayo. It's a 3-pin pluggable terminal block with a ground connection and a transmit and receive connection at 3.3 volts, because the Kayo's native interface is 3.3 volt, which is super convenient. Yeah, so this is what I mean, that the minimum viable thing is actually incredibly simple. All I need is an ESP32 with this connector on it and a USB interface, and I could call the job done, but I'm not satisfied with that. I want the CAN bus interface on there as well, so that I can link it to conveyors and whatever else that I might want to do. So what I can do is, in my protocol converter, in the code that runs on this, which is here, which is all on GitHub as well. So in this code, what it does is it accepts G code and then sends it to the Kayo in the Kayo's native format. Now what I could do is, where is it? Conveyor, adjust conveyor. Yeah, okay, so what I've got is like an M21 code tells it to set the conveyor to a certain size. So from OpenPnP, if I click the little button that says adjust conveyor and type in a number, what it does is send a G code of M21 N93.4, assuming that you want to set the conveyor width to 93.4 millimeters, and then it does it. So, oh, Sion says you want to add audio out, minimum PWM buzzer, or something better for audio output if errors and issues at the machine. Nice. I know you could MQTT error messages, but having it happen in hardware at the line, yeah, that is nice. That is a nice idea. Thanks, Sion. Which reminds me, what I really should do is, should it be there? No, I think I will do it somewhere else. I was just opening Evernote to start taking some notes, but I will not do that. Let's go somewhere different. cd open Kayo. Do I have a notes file? No, I do not. Let's come in here and make this nice and huge so that we can read it, and make some notes. Protocol adapter board? I don't know, that'll do. So, all right, features. What do we want? Everything. When do we want it? Now. So we need USB. I'm going to say USB-C upstream connection to Open PnP. downstream serial 3.3 volt to Kayo. We want audio for alerts, CAN bus to other devices, and I should probably classify this. So I'll say additional downstream USB ports. Yeah, something like that. What else do I want? Everything we wanted yesterday. Yes. All right. I'm going to classify this to some extent. I'm not even sure if this is correct. Syntax. What is the markdown syntax for different levels of indentation? Markdown syntax. I'm sure someone in the chat will tell me faster than I can look it up. I should be using hashes instead. Okay. So it should be something like that. Oops. Okay. Now, oh yes, thank you for reminding me, Keith. Screen connection or power interface for same. Yes. Okay. So nice. By screen connection, I'm just going to say touchscreen. Is that what you're referring to? Okay. Okay, Henrik says, could you add an OLED for the CAN bus to see some information? Yeah. Adding an OLED. I always like to have a little OLED on things just to show status. That's going to... Okay, so touchscreen or OLED. That doesn't actually make sense because a lot of touchscreens are OLED. But, all right, I'm going to say, just to make it clearer, 4.3-inch touchscreen or something like a 1.3-inch OLED. That's just to distinguish the two different ways of doing it. That could be like an I2C or an SPI OLED module. Henrik says, because if you start using CAN bus where you see what the device gets from CAN bus. Yeah, the thing is that it's very fast. If you're doing CAN bus debugging, it's not really practical to throw that information on a display because you'd be getting like 20 messages a second. They will zip past so fast that you've got no chance of reading them or understanding what they are. It's more a matter of displaying things like information that the device has parsed from the CAN bus, like the current XY values, so that you can see the parsed value but not the messages themselves. Yeah. Now, what else? Is there anything else? Probably not. That'll do. That'll do for now. Okay, we will find the task for the OLED, says Henrik. Yeah. I do like putting OLEDs on things, just either an OLED or an RGB LED, because you can show boot status, like whether it's connected to Wi-Fi, whether it's connected to MQTT, all of that sort of thing. So putting an OLED on it, maybe even the same OLED as used on the with the RAC32 that is used on OXRS stuff, could be cool. All Oh, Henrik said, also the funny idea I had before, control the CAN bus with a car. What? Oh, Stephen says, will this board have multiple ESP32 chips on the one board, or are they chained? It'll just have one on the board, and each machine, so where's the photo? There. So each of these machines, at the moment I've only got one machine running. I'm not even using the other two machines at the moment. And each one will need its own Open PnP, like its own computer running Open PnP to control it. So how they interact with each other is going to be an interesting question. That's going to have to be done using scripts, like hooks into Open PnP, so that I can say, for example, send a command saying set your conveyor width to 100 millimeters, and have that same command go to all machines and all conveyors and have them all simultaneously adjust their sizes. But each device will be functionally standalone and self-contained. It's just that it'll receive commands externally to do things. This machine needs to be able to run in total isolation from anything else with OpenPNP as the main brains, talking to the protocol converter, which talks to the machine. Yeah. Chip said CAN bus doesn't utilize a time base. Yeah, each packet has a priority bit. Yeah, kind of. It's more than a bit. It's a set of bits, and it's based on the hierarchy of the IDs of the messages. Was that in reference to... yeah, I've missed most of the chat. Oh, Gerald said, don't forget the don't panic button. Ooh. I was just glancing back up through the chat. So the don't panic button, I assume it actually means the panic button. But, so that'll be referring to like an e-stop. Do I want that on this board? I'm not entirely sure that I do, because the machine's already, well, they already have them. So there's this e-stop here. So yeah, you hit that and the machine stops dead. All of the motors stop. So do I want an e-stop? And it would be a virtual e-stop, not a... So the advantage of this, I mean, you can never have too many layers of protection as well. So there's no reason not to have two. This controls power to the motors. So if you hit this, it doesn't matter what is going on in software. It doesn't matter if the machine things crashed. It will stop. No questions asked. If I put an e-stop button on the controller, what I can do is when it detects that, it can stop sending commands to the machine. But the machine itself will still be live, the motors will still be energized, the servos will be holding their positions, etc. Oh, Don said, might be useful to read the machine e-stop status. Yeah. Oh, and Keith said LED or light connector. And Michael says, technically the big red button could just be a device on the bus. Okay. There's a... typically have NO and NC contacts for dual redundancy, says Trady. Yeah. How to handle this? I hadn't really thought about e-stop in the context of the protocol converter, because the protocol converter is like a little module in the overall system, but it is not really the place where e-stop would happen. You would do that at the machine end, like logically close to the thing that's moving. So when you stop that, it doesn't matter what is happening upstream in the command sequence, like the way messages are getting to it. The upstream computer can keep sending move commands, but the machine is never going to act on them. If you disable the motors right down at the far end. But you were right, detecting that could be useful. So you may notice that down below that, if I can get this, come on. Sometimes the trackpad just does not respond. What? Why can't I zoom? Come on, there, that's better. You may notice there are 3 buttons down under here. I think that first one's green. It doesn't look green there. Green, blue, and white. And I can't even read them. These are used by the original software. So when you press these, I believe it sends status packets back from the serial interface, and then the Windows software can act on it. And these buttons, I think one of them is for like enable or disable. It's like a software enable or disable function. So we can read the status of these buttons. We can act on them. Yeah, I've never even paid attention to them because I'm not using them. Okay, I'm going to go and have a look. Let's see what those buttons actually say. They've got labels on them. But because I haven't run this machine, oh, servo, start, pause, reset. Okay. So, servo. I don't know what that means. But we can repurpose them. Whatever it is that they say they do, we can make them do different things. So the first one says servo, and that's all it says. The second one says start/pause, and the third one was reset, did I say? I can't remember. Okay, servo drive circuit. Yeah, okay. Where is it? I just took a photo. Here. Yeah, reset. Okay. This is the photo that I just took a second ago when I walked in there to have a look. So servo, start, pause, reset. So we can read these buttons and send them back to, well, we can do something with them. Pass it back through to Open PnP somehow. I'm not sure. But anyway. Could you just push the servo button? I'm pretty sure it doesn't do anything directly electronically. I think these are they send messages back to the host computer to do things. But it's possible that that servo button does something directly. Maybe. I'm going to... All right. I'm just going to restart that machine, and maybe then I'll be able to get onto VNC. You know, it's the classic, oh, have you turned it off and turn it off and on again? Restart. Yes, do it. Restart. And then after it's finished rebooting, I'll probably have to log in before I can VNC into it. Peter says, hey folks, please don't forget to like the stream. Feed the algo before feeding your face. No, but your face is much more important to feed than the algo. Right, now, getting back to, where am I? Flipping through all my open things here. Getting back to Eagle. Oh, piezo beeper. I already had one on there, Sion. But this one is just like an enunciator. It's not PWM capable. It's got a built-in driver, which means that you can kind of make it do different tones, but not super effectively. Couldn't make it play music. Stephen says, or use 4 inputs and monitor the Estop as well to pause commands being sent. Yeah, okay, so that's the whole Estop question is interesting, and getting feedback from it. I think it might be Don S who, oh, I just set aside 3 input pins, servo drive. Yeah, okay. I am missing... Yes, it was Don S. who said, might be useful to read the machine Estop status. All right, so that's getting back to where we were 10 minutes ago in my random blathering. I don't even know if it's possible. Read Estop status. So what I need to do is check whether pressing the Estop makes any sends any message back out of the serial interface of the machine. I don't think it does. I am pretty sure that the entire power for the machine, including the motion controller, runs through that Estop button, which means if I hit that button, I'm never going to get any messages back from the machine. It's dead. And my protocol converter could still be powered up because it'll be powered off the host computer. But, oh, Trev said, could you make it play Toto Africa like old mate did on his Volvo door chime? Oh, I've got a meme about Africa. Hang on. And I saw it just recently, so I don't think it's too far back in my history. There was a theory about, no, not this one, about Toto's Africa and the meaning behind it. Yes, I know this is a squirrel, but that's why we're here, right? Is it this one? No. Sorry, I'm scrolling back through my pictures, although it may not even be here. I think it might be on my phone, but not on my computer. Yeah. Anyway, it was a theory about the meaning behind it, and the end result was that, yeah, the thing is, why was the protagonist in Africa? And the end result, following the logic of all the things that he sings about in the song, is that he's a lovesick werewolf searching for a magical solution to cure his condition so that he can be back with the one that he loves. And it makes total sense in the context of the lyrics of the song. Back to here. I am more jumpy than usual today. Okay, so read Estop status. Okay, so that's a want. If there are still any comms coming back out of the machine when you hit Estop, and I must admit, I've never actually tested this. I haven't checked whether the onboard controller responds to anything when Estop has been activated. So I'll put that in as a want, but I don't think there is any... Well, I could modify the machine. This is the other thing, is I'm trying to minimize modifications. What I could do is wire into the Estop switch, so I could actually detect the state of the switch. But it's switching mains, and so what I would do is I'd have a mains relay, 240 volt relay, or some kind of other opto-isolated thing attached to it so that I could read whether there is power on it. But all that would do is tell us whether there's power on the machine, not necessarily whether it was because the machine was turned on or because Estop had been hit. So I have a feeling that reading Estop status is going to be not practical without modifications to the machine and running additional cabling into it. So I'm going to leave that in the want. Now the other thing is, I'll put it in here, read front panel buttons. Now this is not actually a feature of the electronics of the protocol converter, because I think, as I was saying before, when you press those buttons, it makes the machine send status messages coming, back out of it. but that will be a software thing. Now, oh, James said industrial e-stops and buttons can have extra contacts. That would be convenient. Yeah, I'd still prefer to minimize extra wiring into the machine. Like actually getting into the back of that e-stop location is not trivial. Just because of the way the machine is structured. I can get the, the wiring is inside one of the corner pillars of the machine, which is fully enclosed. So it'd be like a fishing job through a welded steel channel. Yeah, right. Now, oh, so John Whips. I don't think I've seen that name in chat before. So, welcome. Surely eStop is much safer in hardware as a software message interrupt processor could hang, fail, reboot, etc., leading to undesirable results and lack of immediate curtailment of a process. Spot on, exactly correct. Yes, that is why this sort of eStop, which just interrupts the power directly, is the best, because it doesn't matter what else is going on. If you hit that button, that machine is going to stop. Nothing will make it move. Yeah. Yes. David says, should be pretty easy to do though, the wire fishing. Yes, that's true. All right. In that case, I am being talked into having additional inputs to read from the eStop status. So I'll say spare input, something like that. And that, I'm going to have to investigate this. Read front panel buttons requires only software as a question, because it may be necessary to hook into the buttons to read those as well, which would mean more inputs. Okay. I'm just wondering if I should put these into the nice category or the want category. Because I kind of am going to do the, and I'm thinking of upgrading, no, okay. I was thinking of upgrading CAN bus to other devices. But when it comes down to it, okay, my three classifications here of essential, want, and nice. Essential, this is what has to be on it to be able to control the machine. And that really is all you need. USB-C connection and a downstream connection. And then the wants are the things that I intend to do. Whoops. So audio buzzer, CAN bus to other devices. I'm going to do that. There's no question about it. It's going to be done, but I'm putting it in want because it's not actually essential to make the machine work. Read eStop status, maybe, and read front panel buttons, maybe. I don't actually need these. And then nice additional downstream USB ports. I'm kind of inclined to upgrade that because I'm pretty sure I want to do it. And I'm going to downgrade these. Yes, downgrade status. Downgrade safety. Look, now we can say safety third. It's in the third category. Oh, Henrik pointed out also there are lights integrated with the buttons, remember? Yes. Lights? Yeah, so there are some things to investigate here. But I still want to get on with at least doing some of the design of the board. And now, oh, Mike says we had to tape a plastic cover over the eStop on one of our satellite dishes in New Zealand to prevent curious possums disabling the dish while awaiting a radome to keep critters out. Oh, pesky possums. Henrik said, but can we test the buttons when the thing is up? Oh, and James says, why read the front panel buttons? What about doing a remote press of the buttons? Yeah, this really gets down to the crux of it, which is, do I care about those buttons and what they do? Was it there? Yeah, and I think I don't, because I control it all through OpenPnP anyway. Hang on, I got a cough. The cough button did its job. All right. Back to here. Yeah, these commands, servo, start, pause, and reset. These are not things that I'm going to want to do standing in front of the machine using a hardware button when I control it through the OpenPnP interface anyway. I think, unless start, pause might be useful. Maybe if I was on the machine, I wanted to pause the job to do something, like fix a feeder or whatever. But yeah, this is very secondary. I don't really actually care about these buttons. I've been running the machine. This is why I had to actually go and look at the machine to see what the labels were on the buttons, because I've never cared. So, Henrik says only 44 minutes left. No! Oh, Stephen says adding a USB hub with a couple of connectors is simple. Yep. Alarm reset maybe, or is there an HMI for it? You can pause with the Estop. Not with the hardware Estop. It'll stop the machine. Yeah. That is like a panic, someone is going to lose a finger type situation. Hit that button, or the machine is doing something really bad and has overrun a limit and is about to it is trying to destroy itself. It is not, you do not use the E-stop in a situation that you expect to recover from elegantly. If you hit that E-stop, things have gone very bad, and you're going to have to do some work to get yourself back running again. So that's why there is that the start pause button is more of a software thing, like hit the pause button and it'll stop sending commands to move the machine while you do things, and then you can resume. But E-stop is, yeah, jam on the brakes, bad things are happening. So, now, okay, USB. All right, so something that would be useful to, where are we? Here. So a few years ago, I did some work for a company here in Melbourne, working on a robot, and I worked on a USB hub that went inside the neck of the robot. Hacker hub. Okay, so this was before Austin did his little thing. And then, so backstory. What I really wanted was a USB hub that that allowed me to do things like control power to each of the ports and monitor power to each of the ports. I don't have it implemented in here. For doing basically a useful USB hub for hackering type activities. And I got as far as this in the design. So when was this? Where's the date? Okay, August 2020. So 3 years ago, I was working on this. And where's the hardware part of the design? There. What the hell is going on with that? So there's a big module hanging off here, a power module. Part of the idea was that I wanted to be able to put lots and lots of power to downstream devices as well, because I was sick of hubs that did not supply enough power. So this is using a TUSB 2036, and it is, I don't know what the 6 means, but it's a USB 2.0 hub chip with 3 downstream ports. My guess is that that's where the 203 comes from in the part number, and I don't know where the 6 comes from. And so that was the particular chip that we used in the neck of the robot, and I have successfully used this in a design. So that was before this. I'd successfully used this chip in that design, and I have some right here left over from that project. So the simple thing was just to use this. So this particular thing, it's a 3-port hub with 1 upstream. So you get 4 USB connections. 1 is the upstream connection. Let's go back to the schematic. Where are we? Okay. There's no connector on that in the schematic. That connector must be just hanging out, doing its own thing. Where is that connector? I don't even know where it is. Oh, it's there. Okay, so that is the upstream connector that I had just mocked into the design. So what I did with this was I took part of the hub design that I worked on for that robotics company and started putting it into a form factor for like a more regular hub, because the one that I did was in a bizarro shape. In fact, I'm going to show you. Yes. I'm sure Marita won't care anymore because she's not running this company anymore. So this was for Marita Chen. Where was it? In fact, I'm going to pull this. I just realized that if I open something, I'm going to show you the names of clients who I am under NDA. I can't actually even tell you the name of the client, let alone the project. But this was different. This one was okay. Where, if I can find it? No. Where is Marita's project? Okay, I'm going to find this because I'm going to show you the USB hub. It was kind of funky and fun. Alright, so I haven't looked at chat for the last couple of minutes, but what I'm hoping is that people will have suggestions for good USB chips to use. So this is a fairly old chip. It's a USB 2.0 chip, and let's see. No, it's not in there. Where? Oh, because this was so old, it's possible that I had her project not classified in a client section. It might have been. I'm not even sure how I find it. That's how far back it goes. So, Marita, let's see. No, I don't know. I am becoming kind of frustrated. Hang on, it was called neck. Ah, here we go. I think I might have found it. Let's open this folder. Neck hub. I'm not sure if this was the most recent. Yes, I think this is it. Okay, this is it. So this was for our bot, for Marita Cheng. This is a telepresence robot, so people with disabilities could drive the robot around and be in a different place. And so there were some weird requirements for this hub in terms of the way the power worked and different stuff. Anyway, this hub fit inside a tube, the neck tube of the robot, and it used pogo pins for connection. So the idea is that you could disassemble the robot by just grabbing and twisting and pulling segments apart like a vacuum cleaner. And this latched into parts of the mechanical structure of the neck so that it would, it'd all be held in place. And so these were the USB connections coming off here for a couple of things, like there was a speaker and microphone, which was a USB based thing, which was mounted on the neck of the robot, and one of these was the connection to that. And then there was an upstream connection, and there was a connection to the motor controller, I think from memory. Downstream went to the motor controller, which was in the base of the robot. Accessory 1 was for the speaker microphone thing that was attached to the neck of the robot, and upstream went to the main controller, which was dealing with all of the overall movement of the robot. So this, what is that voltage regulator? And that is a horrible footprint. That should have, all of those thermal grounds should have been, where is it? LM2574. Okay, yeah, it's one of the classic LM series voltage regulators, switch mode regulator. So, excuse me. Yeah, anyway, this was done by for Albot. Albot doesn't exist anymore, and Marita is off doing other things, so I'm sure she is absolutely fine with me showing this, and this is only a tiny bit of the robot. So the where are we? Board. Anyway, that was the point. This was a funky USB hub design that I worked on back like 5 years ago, 6 years ago-ish, something. And that is what led to, now I've got to come back into here and find this. Okay, oh no, wrong one. Hacker Hub. Anyway, doesn't matter. So what I was doing was working on Hacker Hub, and what I was calling Hacker Hub, but then got sidetracked because that happens sometimes. Only rarely, but it does happen. And then Austin was working on his hub, which was really, really cool. So then there was no need for me to do mine. So I just dropped it. And hang on, Eagle, I'm going to open that up again. Where is Hacker Hub? Here it is. All right, so this was me beginning to take the design of that USB hub and put it into a form factor that was not some weirdo ninja throwing star designed to go inside the neck of a robot, and add USB connectors and put it onto a rectangular base and add a power connector, and that would be some big fat voltage regulator module. I wouldn't do it this way now, but this was a few years ago, and that's the approach that I was going to take. So what I'm thinking of doing is basically just transplanting this into, in fact, let's just, for the hell of it, let's just do that. What have we got? Don't care about the power supply, USB hub. Yeah, that'll do. In fact, let's stuff it. Let's just take the whole thing, and we'll make another sheet. And copy. Copy that now. Copy that, Utah. Where did I put it? Where did I put it? I want to find OpenKO there. All right. Let's add a sheet. Add a sheet. New. Come on. Why can't I add a new sheet? New. What? Why are you being strange? New. New, hang on. What is going on with Eagle? Why? Am I being brain dead? I should be able to just go new sheet. Maybe, could it be because I've got stuff in the clipboard? I don't know. Very odd. Surely not. That wouldn't stop you from adding a sheet. Oh, the other thing is, yeah. Okay, there is a whole extra thing that I could be ranting about in terms of Eagle, but hey, let's not do that. Well, there's a spanner in the floor, in the gum in the works of the plans. How do I make a new sheet in Eagle? Right. Is there something? Yes. KeyCAD says, Sion says, KeyCAD for the win. Unexpected maker. Your Eagle license is expired and is now deleting your projects. Try to click on other places on the right. Yeah. I don't know what's going on with that. Yeah, I wonder if it is actually a license thing. I wonder. That is quite possible, because one of the 2 days ago, Autodesk, or a few days ago, Autodesk migrated their license management system to a new platform. They were using a platform where you would manage your software, your subscriptions to different Autodesk products, and they've just switched over to a new platform, and yeah, can't do anything. And all of my subscriptions have disappeared. So it could be that it just thinks that yeah. Austin says, really do need to migrate your stuff, even more with the end of Eagle. Yes. I really just don't like KeyCAD though. And I don't like the lack of integration with Fusion 360. And I can't stand FreeCAD as an alternative. I've used FreeCAD a little bit and I just hate it. HM says, good enough for CERN, good enough for me. Yes. Henrik says, so it thinks you are poor now. Yes, exactly. Austin says, Google says, yes, in free you're limited on sheet count. Yeah, that is the usual thing, is that on the free version. So I think it's thrown me to like a free license version, even though I have a fully paid up version. In fact, if I go into, it's going to take a little while. Sion says, good enough for Sion, good enough for John. Yeah. Oh, Scott said, learning FreeCAD while watching the stream. Stephen said, alternatively, you spend up on Altium. Don said, let's start a Fusion fund. No, the thing is, I don't need a Fusion fund because I have a license. Like, I've fully paid for a pro license, which means that I automatically get Eagle full pro license as part of it. I've had that for years and years. I started when in the early days of Freetronics, so maybe 13, 14 years ago. I was using Eagle then, and I paid for a commercial license for Eagle very early on, basically because the way the licensing worked early on was, I'm launching Eagle on my other monitor and it says I'm on a trial which ends in 29 days, despite the fact that I have a full pro license. So I've been paying the pro for Eagle for 12 years, I think, when it switched over to Autodesk. Yeah, so look at this. I'll just bring this up here. Up here it says, subscribe now. It's under the Superhouse logo, but yeah, here you can see things that I've been messing around with. Kayo E4, what have I got in there? Discard tray, camera mount. I've just been doing ventilation stuff that goes onto the reflow oven. So I've just been printing out an adapter where the silver flexible duct that is used on extraction fans and things, that goes onto here. I've actually printed this now. I was doing this yesterday. So the duct goes over this, and then you put tape around it, and then this is like a magnetic clip thing that goes onto the top of the reflow oven for the extraction system, fume extraction. But despite me paying them a lot of money every year, Autodesk now say subscribe. Okay, so that answers the question. That is why I can't actually add a sheet in Eagle. Austin says, part of the reason to migrate people and changing program names is to get rid of the people that have perpetual licenses. Yeah, but I'm paying it the subscription license. That's right. So what I was saying was that the reason I did that is that Freetronics was commercially making things using Eagle and selling them. And so the correct thing to do was to pay for a commercial license. So even though a lot of people were just running with the hobbyist license, I've actually been paying for the commercial license all of that time. Anyway, well, I suppose there is one nasty way we can get around that. Which is the the poor man's multi-sheet. Conflicting, no, do not overwrite. Here we go. Screw you, Autodesk. If you won't let me make more sheets, I'll just make a really, really big sheet. Do the license software to upgrade. What am I doing? That little side rant sort of sent me off. Okay, so let's just getting back to way back at the start of the stream. I've got a Vroom 32 on here, but what I'm thinking of doing is going for something a bit different. I was thinking of, let's go for this instead. Let's go, boink. Stick an S3 in there. And look at this. Got all these parts for the a lot of this stuff I'm just going to delete. This is at the random just moving stuff around part of the process. So that is all of the USB hub related stuff. Come on. Oh, that's the other limitation. You see this? I am in a negative coordinate here. This is bizarre. I'd forgotten that this even exists. One of the other limitations on the education, like the free version licenses of Eagle, is there was a board size restriction, and so it wouldn't let you put things in negative space. So what I'm trying to click here to put this down, and I am left of the 0 origin point, so it won't let me put this into a negative coordinate. I have to put it over here on this side of the board, and then I can put it down. Oh, that's weird. Oh, and it won't let me put it down up here because that is outside. Yeah, see? I can't put it there. It's outside of the allowed board dimensions. Screw you, Autodesk. I've sent you $1 bajillion over the last 12 years. Well, not entirely to Autodesk. Originally it was to CAD Soft, who created Eagle in the first place, but then it's been Autodesk for the last few years. And now they have wiped my license and I can't use it. Maybe this will turn into the live stream where I say, screw this, I am switching to KiCad. This sort of bullshit really, really does tempt me. Even though the tool seems so much better, it's just annoying. And the thing is that I am happy to pay for a good tool, but then the licensing, like the license management stuff, gets in the way and doesn't let me use a tool that I have paid for. All right, now back to schematicization and thinking about this. All right, USB-C upstream connection to the OpenPnP, downstream serial 3.3 to Kayo. Now, buzzer, got that. CAN bus for other devices, got that. Additional downstream USB ports. All right. Now, where are we at? Where are we at? USB-C connection, USB to serial converter, all of that is going to go away. Auto reset, like all of this part of the circuit is related to the original series ESP32. So with great pleasure, I think I could, as Ellie says, bye-bye, dude. Throw that magazine out of the car. What else? Okay, so power supply, do I want that? Do I want that? No, I do not want that. I got a whole lot of duplication here, so I'm gonna just drink and doink this one. And power jack, do I want that? I don't think I do. I think I'm just gonna, oh, maybe I do. I want power for downstream devices. I don't want this voltage regulator though, so I'm gonna doink that one. Delete group, bang. The USB hub. All right, I'm gonna get rid of a whole lot of stuff off here because I'm just using this as my scratch pad. Yeah, thing. To USB 27.7 and expand to 7 ports. I don't care about that. USB port 1 protocol converter. That'll do. USB port 2 can be to, I'll just say the camera. Oh, no, camera, doesn't matter. It's going to be aux. Auxiliary, is that how you spell it? I don't know. Auxiliary 1. I'll just say aux because I don't know how many L's are in auxiliary. Aux 1 and port 3 is to aux 2, just to be really confusing. 2 is to 1, 3 is to 2. So I should call it aux A and aux B. So I do not need a USB-C connector on here. So kaboing. That is going to be going to the ESP. Now I don't need this ESP, but what do I want to keep out of this? Okay, so I've got Kayo, I've got the CAN bus interface there, I've got I2C, TX there was going to the USB to serial converter. That does not exist anymore. So let's just kablamo this. Piezo, what I'm doing is keeping these stub nets as references to myself, so that, I could just do it this way, couldn't I? Quicker. So that, no, I want that. I know which things I need to add. Now, what I'm going to need to do is convert. Oh, that was one of the strapping pins So I'm going to have to add some strapping stuff to this. Oh, my pinists there are going to be wrong because I'm going to have to do the conversions now for the S3 instead of using the original ESP32. 13 minutes, says Peter. Oh, Emily says, I'm glad there are always people out there creating open source software and providing it for free or very affordable pricing. Absolutely. I agree. And, yeah, maybe, I kind of feel like I need to justify my use of Eagle. But what it comes down to is, it's partly legacy, and it's what I'm comfortable with and efficient in, and also the investment in 13 years worth of creating libraries and associated 3D parts and footprints and assembly jobs like production files and Open PnP jobs and all of the other things, and just muscle memory. So what am I going to do with that? Why did that? Okay, what I'm going to do is update all libraries because, yep, DRC is going to fail. Because, and I don't mean to say in any way that KiCad is bad. It's not like I'm saying, oh, KiCad is a bad piece of software and I don't want to use it. KiCad is incredible. It's this is one of the things I do when I'm just doing actions and not thinking about it. You're just clicking around. I'm just fixing these. I could explain what I'm doing, but I'm not going to bother. There is actually a good reason for this. Yeah, it is a really cool piece of software. It's just that I have a work that doesn't use it, and I very much appreciate the fact that there are people working on it, and that it's a great piece of software. It's just not the one that I use. Now, will I use it in future? Maybe. In fact, I'd say more than maybe. It's a fairly high probability that I will. And yes, I know the longer I put it off, the worse it is. I should just do it. Now, where am I? Okay, so USB hub. What I want to do is bring this USB interface in to into here. D plus and D minus USB on the Vroom 32. Let's just move that. Let's stick it over here somewhere. D plus, D minus. Oh, it's even the correct way around. Isn't that nice? So we can say D minus to there, D plus to there. And I'm going to get rid of these resistors because it's a directly connected device. Yes, I do want to do that. And yes, I do want to do that. And just for neatness sake, let's bring this up here. Dun, 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 dun. All right. This is the stage of the project where it looks like I'm just fiddling around, but I'm just dumping major things in as a starting point. So what we've got now is a connection here. This is going to be the upstream connection, and also I'm going to change the way all of these things are done. If I move that, stick it down here somewhere. So then, where is it? Where's plus? Plus is on the top. I'm going to have to switch that plus and plus. Okay, so I want, and I'm there. Oh, this is kind of messy, but it'll get there. right through the middle of a resistor. Let's stick it there. It's going to need a whole lot of cleaning up later. So we've got D plus coming from the USB connector, passing through to D plus on the upstream port of the USB hub, and minus going to minus. DP pull up, okay, cool, whatever, don't care. There is obviously a whole lot of, I could be very methodical about this, but I'm in the early stages of projects. This is what I tend to do, is just, it looks like I'm going very fast and just jumping things around all over the place, but really what I'm doing is in my head, I'm just shuffling the major pieces into place to match approximately what I've got here in terms of what I want it to do. So I'll just keep referring back to this, and am I covering my original objectives, and just stick major pieces in place here and then figure out all the details later. And then later I will put TLC into each of these things and make sure that it is what it should be. Like I'll start cleaning up the schematic and arranging it so that all of the designators are easy to see, and power connections or anything else going to this, but that will all be fixed. So what else do we need? Oh, and I'm going to change this. This is all going to get replaced. So in fact, let's nuke that now. There's a big gaping hole where the 5-volt regulator should be. And okay. Now here is something to note about power management. To essential. This is not, it's not a feature. This is more a design note. Okay, I'm going to add a section down here. I'll say design notes. This is for my own future reference. So I'm going to say power management. All right, now from USB-C upstream, useful for dev. Power from external. What's it going to be? 12. I don't even know what's available for this sort of thing. I might just plug in a plug pack or something. This is just note for myself. Now power from for running downstream, etc. Because there are going to be other things. Here, there could be, my face get that face out of there. There could be a camera into here which could draw a bit of power. Another Arduino, and that is probably what's going to be plugged in here. All of this is to say it is probably not going to be sufficient to just pull power out of VBus here and expect the upstream computer to power everything through this. So what I think I want to do is have an external power source, like a 12-volt power source or something, which plugs into this, and then run a regulator. And do we even need 5 volts? What do we need 5 volts for? The USB hub runs at 3.3 volts. Maybe we don't need 5 volts at all. I could just go straight for a, I could take whatever the input is and go straight to 3.3 volts, put a switch mode regulator in there, something like a an LM380 10, and dispense with the 5 volt. Yeah, I don't know. I don't know if 5 volts is useful to me. Anyway, all of this is me just thinking out loud, trying to puzzle through this thing. External power from external source for running downstream camera, etc. What you're seeing is kind of an insight into the randomness in my brain as I'm working on these things. So when I'm working on projects, I'm juggling all of these considerations in my head. So power from external source for running a downstream camera. So I would want some isolation between those two. So if I have 5 volts coming in from USB, from the upstream connection, that could, okay, so is that enough overhead? 1.7 volts to take 5 volts in, feed it into a 3.3 volt switch mode regulator. So the regulator is going to have 2 possible sources of power. One is from upstream USB-C and the other is from an external power source. So it'd be nice to be able to run this without an external power source if there are no extra peripherals plugged in. The other thing is power on, yes, okay, CAN bus. Oops. Okay, power 2 from CAN bus. Yes, I need to remember that as well because, oops, I have here, where is it? Back on this sheet. All right, I've got this CAN bus interface, and on this is a 4-pin pluggable terminal block, a screw terminal, which is like a standard format that I use on lots of projects. I've got it on my, in fact, let's have a look at that conveyor. Where is it? Conveyor, controller, where? My project's names that I can find again later. Where is the conveyor controller project? Am I even in the right folder? I don't know. Oh, what? What's the time? Use 48 volt on all the things. What could possibly go wrong? Says Peter. The time has gone. Oh, Stephen, you are 100% correct. Thank you for pointing that out. The USB aux ports need 5 volts. That is an excellent point. Downstream USB devices need 5 volts. Yes, so I definitely need a 5 volt regulator in there. All right, so the way this will work is power comes in. All right, so I'm just going to power sources, upstream USB, USB 5 volts, external power connector, I'm going to say 12 volts for that, and the reason is want to supply other CAN devices, and I normally use 12 volts for things for that purpose. So just because it's common in cars, I suppose. All right, power sources, and then I'm going to say power sinks. There is going to be downstream USB devices, 5 volts, and there is going to be us, like our own device, 3.3 volts is required. Then we need downstream CAN devices, 12 volts. All right, so power can come from either of these places, and it can go to any of these places. Peter is sending me messages saying go eat. Yeah, actually more than go eat. My friend David is competing in a jiu-jitsu competition this afternoon, along with a few other people from the gym, who are also my friends, but David is one of the people I train with very frequently, a few times a week. It's one of my regular training partners. And this is his first ever jiu-jitsu competition. And, I'm going there to watch. So it's at Monash Uni, at the Monash Sports Stadium. There's something like 700 competitors. It's like, Can it really be that big? I saw some big number on the registration form for it. So yeah, I'm going for that. His first match is at 2:18, I think. So it's just over 2 hours away. So I do have time. And Adrian, who is another person from the gym that I train with, his first match is at 1:38. And I want to see his as well. So I've got a little bit of time, but I don't have a lot of time to hang around. Now, John is in a time warp. Stephen W says 12 or 24 volts for V-Raw on the CAN bus. I am going to, yeah, I'm going to do 12 volts. Now, the other thing that I was trying to find, I'm just going to switch back to Eagle because I want to find my, I've got so many projects, so many, like just scrolling through my Eagle projects directory takes a while. And when you don't know what you're looking for, oh, here we go, PCB conveyor. I wasn't looking under P, I was looking under C for conveyor. I've just found it. PCB conveyor. All right, this is, and let's turn on some other layers. Turn on the bottom layer. Okay, so this is my project for making the controller for the conveyor belt that goes between the pick and place machines. And it uses, what is, I can never remember the thing. That touchscreen, yeah, the WT32SC01. Oh, look, it's still got the template. I haven't fixed the SKU. So 2 years ago, I did this. Oh, what has happened to time? The calendar is broken. Yeah, so the WT32SC01, which is the ESP32 based touchscreen, this board plugs into the back of it, and it has connectors for step sticks for the stepper motor drivers for X and Y axis. So X axis, which is left to right, is running the conveyor, and Y axis, which is front to back, is adjusting the width of the conveyor. So that moves a stepper motor to change the width of the conveyor belt. And there is a Y-axis limit sensor, which it uses for homing. So it homes the Y-axis, and then you can set whatever size you want on the conveyor. And then the I/O expander is used for extra things like ready in and ready out. So when you have machines in a production line, they have to talk to each other, to their neighbors, so that they know when they are ready to receive or output whatever it is that they are moving. So we've got left in, left out, right in, right out. So it's got ready in and ready out signals on both sides. And so this will talk to the pick and place machine. Like it could be between two pick and place machines, for example, and it will communicate so it knows when, all the devices will communicate so they know when to pass boards between them. This has a CAN bus interface on it as well. So the point of bringing this up is that this is one of the other devices that will be on that same CAN bus. And you can see that it's got two CAN connectors on it. And once again, it's this 4-pin pluggable terminal block that I use on everything. It's got, so there are two CAN connections. There is CAN termination with a jumper on it, so you can enable or disable it. It takes power off the CAN bus through this Schottky diode to VIN, and there's the CAN transceiver connected to the ESP32. Oh yeah, so there's the here's the opto isolation and the relay that is used for the ready in out signals. So one set of ready in and ready out for the left interface, probably the upstream machine in the production line, and ready in, ready out on the right interface, which will be the downstream machine in the production line. What is that? Power switch, okay. 5-volt regulator, blah, 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 don't care, PCB sensors. Oh yeah, that's sensors so that it can detect when a circuit board arrives at the input of the conveyor and to detect on the output of the conveyor, assuming that it's a left to right run. You could do it reverse, of course, but I've just marked it left and right. So this is what else will be plugged in on that same CAN bus. So if we go back to our thing here, this thing here. Okay, so we've got VRAW here, and what I'm doing is standardizing for my purposes here on my production line on 12 volts as the raw voltage. Now I'm going to be either sending or receiving 12 volts. So I think that what I need to do is have the possibility of isolating this, because there are going to be multiple devices, any of which could be powered, any of which could be supplying power or consuming power. So I'm pretty sure I need to be able to isolate the 12 volt. Peter says, I'm not listening, John. I've turned the audio off. It's for your own good. Cable Tie says, Lola puts fingers in ears and sings la 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 la. Okay. Yeah, I should stop. Henrik says he's fixed the PCB. Yeah, but I won't do it on this stream. Thanks, Henrik. That's really good to hear. And that is a really cool project. That's the oscilloscope project. But we'll have to follow that up another time. Okay, so this is devolving into the point of random notes. Power to from CAN bus. Include jumper to isolate. All right. So 12 volts because we want to supply the devices. Yeah. All right. Yeah. So power is going to be a surprisingly complicated. Complicated is not the right word. A surprisingly important aspect of this design, because we've got all these different devices connected together. And we've got 5 volt devices on USB, and we've got 12 volt on CAN bus. And we could be powered off CAN, or we could be powering other devices off CAN. So, yeah. I think what I'll do, at first glance, it seems obvious that what you should do is include a something like a diode here, so that we've got 12 volts on our local device through a diode supplying the CAN bus, which means that it can't get power back from the CAN bus, but it will supply power to it. And if we have multiple devices connected like that, all with diodes, it should be safe. You could have a few devices all supplying the bus. The problem is that we might want to be consuming power from the bus as well. If this was the second machine in the chain, for example, I might want to have it use power from the first machine coming through CAN bus, and the PCB conveyor controllers will be consuming from CAN bus as well. So I think the thing to do is VRAW. I should rename that. What do we call this net? I'm going to call this net. Oh, hang on. Before I do that, where else is it? It'll be up here. VRAW. If I rush into this now, I'm probably going to screw it up. So it's going to take careful thought to make sure that I am not setting myself up for a bad power situation here, because I've got VRAW here, which is connected to the CAN bus, and I've got a fused thing on the internal side. So I need to lay out my power sources. power jack. Do I want to use that, or do I want to use pluggable terminals? Or do I want to use XT60? I think I want to use XT60. I think I do. Will I? Won't I? Yes. All right. Where am I? XT, because I've used that in so many other places. XT60 PCB mount, and I want it to be that one. I may change my mind on this, but just for now, I'm going to use XT60 as the signifier of the main power coming in, and I'll give that a value of 12 volts DC. That will do. I'll get rid of the power jack, don't want that. V-rod, so I'm going to need a jumper. I really should stop. I'm thinking through the power arrangement here with a jumper to pass power or to isolate power from the CAN bus. But that's going to be a job for another day. Let's leave it there as a mess with stuff everywhere. But if anybody wants to check out my and laugh at my poor coding practices, have a look at GitHub. Where is it? Not PCB conveyor. Open Kayo. Is that it? Just checking if I've got the right URL. Yes. Okay. So this is all on GitHub already, and it has been for quite a while. The hardware does not exist, so that is a lie. But the firmware in here is actually all there. Well, this is what I just had open a minute ago in Arduino IDE at the start of all of this. This is actually functional right now, amazingly. You can load this code onto an ESP32 plugged into a Kayo pick and place machine, and you can drive it around. It's a miracle that it works, but the proof is in that video I showed earlier. Here, this is it. That is Open Kayo acting as a protocol converter. So, I know. Imi says, Jono has achieved flow state. It's the creative equivalent to enlightenment, 120 ohms. Yeah, I know. This is the thing, is that I've got into that state where I am really into this, and I want to keep going, but I really also should go. So, let's get rid of that. And this. I want to get this done. I want to get it done. But maybe what I need to do is, before the next live stream, and I mean like immediately before, like in the 10 minutes, 15 minutes before, get started on messing around with this in Eagle so that I'm already underway and starting to get into that state, and then just hit go on the broadcast, and you can jump in, and I'll already be underway, so you can, I won't have all the blathering around at the start and taking an hour and something before I even begin to get going with it. Or maybe I should just do it as a random off schedule stream sometime. Maybe that'd be interesting. Yeah, sometime when I'm wanting to work on it, I will just hit the stream button. All right. Thanks everybody for coming along, and Thanks Autodesk for locking me out of the subscription that I've paid for. Grrr. Okay, I'm gonna go. I'm gonna grab some food and I'm gonna go and see David and Adrian and Terry and Dean all do their jiu-jitsu stuff and try to break people's arms and legs and strangle them unconscious, which is always so much fun. It's fun when you're doing it to someone else. Not quite so much fun when they're doing it to you, but still fun. So, where's the off button? There. Okay. Thanks everybody, and go build something awesome.